I am Anil Kumar. Welcome to my series on functions. We'll have an example based on inverse functions in this particular video. And we'll also look into the transformation from the function to the inverse function. Example is based on a rational function. In case you want to learn from me more, you can always send an email on the address given here. Also, check our website for the latest videos. Question for you here is, consider f of x equals to x minus 1 over x minus 4. Write domain and range of f of x, find f inverse of x, write domain and range of f inverse x, and most important, describe the transformation that maps y equals to f of x onto y equals to f inverse x, right? So this is the major problem which we need to consider, that is the transformation from the function to its inverse. When we are given a rational function f of x equals to x minus 1 over x minus 4. You can pause the video, answer the question, and then look into my suggestions. We'll actually begin with understanding the question and what kind of strategy can we adopt, and then we'll provide a solution. When we are given the function f of x equals to x minus 1 over x minus 4, as far as the domain is concerned, denominator cannot be 0. So we know x minus 4 is never equal to 0, and that means x is not equal to 4. So that is a restriction on the domain. Now to find the restriction on the range, we can find the horizontal asymptote. Now in this particular function, horizontal asymptote is when x approaches a very large value, let us say plus infinity, then what happens to the y value? Well, in the case of f of x, if x approaches a large value, then the function could be written as x over x, right? We can also do like this. We can take x common in this and we get 1 minus 1 over x, and in the denominator we can take x common, we get 1 minus 4 over x, correct? So in that case we can now cancel these x, and when x approaches a very large value, let's say infinitely large, in that case the term 1 over x approaches 0, right? And therefore f of x actually approaches the value which is the coefficient of these numbers, and that is 1. So that becomes the horizontal asymptote. Is that clear to you? So finding horizontal asymptote gives you a restriction on the range. I've actually sketched this particular graph here. The graph in red indicates the function which we are talking about. Now here you can see that at x equals to minus 4, we have a vertical asymptote. And at x equals to 1, y equals to 1, we have a horizontal asymptote. So those are the restrictions. Therefore, y is not equal to 1. Correct? So these are the two restrictions, and they give you domain and range. So we could answer the very first question, and related to that, we can also answer the third question, which is what is the domain and range of the inverse function? Correct? Because we know if point x and y is on f of x, in that case y and x is a point on f inverse x. So we actually swap domain and range, correct? And therefore we can answer the third question also from here. Now we'll also see how do we find inverse by swapping and then isolating the y. Okay, so let's begin with our solution now. You can also pause the video at this stage and then find the solution. So as we discussed, now let's write down what is the domain of this function. So the domain of this function is that the denominator cannot be equal to 0. And therefore, x is not equal to minus 4 is the domain, but x can have any other real value. As far as range is concerned, y is not equal to 1, this is y, but it could take any other value. Since this y equals to 1 is a horizontal asymptote, you get the idea, right? So this is the horizontal asymptote, y equals to 1, and we do have a vertical asymptote, which is x equals to minus 4. Is that clear to you? So that becomes the domain and range for f of x. Clear? Now, to find the domain and range of inverse of the function, we just swap this, correct? So this part, which is the domain, now becomes the range. So we say range is that y belongs to real number, but y is not equal to minus 4. And the range part becomes the domain for the inverse function. So they swap. And therefore, we can write the solution for 1 and 3. Correct? Now let's look into the next part, and which is how do we find the inverse of the function. So to find the inverse of the function, which is x minus 1 over x plus 4, what are we going to do? We'll write this function as y equals to x minus 1 over x over 4, and then we are going to swap x and y terms, correct? So when you swap x and y, the equation becomes x equals to y minus 1 over y plus 4. And now we are going to isolate y. So do cross multiplication, right? So we do cross multiply, and we get x times y plus 4 equals to y minus 4. Now bring the x terms and the y terms to different sides. So bringing y to the left side, we get xy minus y equals to minus 4x minus 1, right? So we did the distributive property, expanded, correct? And then we simplified by bringing y to the left-hand side, taking it as a common factor and then dividing by x minus 1, we get the inverse of the function in the form minus 4x minus 1 over x minus 1. So here is the inverse of the function, which is minus 4x minus 1 over x minus 1. Correct? So that is how you find the inverse of the function. Now from the inverse of the function also, you can actually write down the domain and the range, correct? So the domain is that x is not equal to 1, as that gives you the denominator as 0, and the range is the ratio of the coefficients of x, which is minus 4 is not included, right? So that is your horizontal asymptote, correct? So the horizontal asymptote is y equals to minus 4, and the vertical asymptote is x equals to 1 for the inverse function. Is that clear to you? And so we can write down the domain and range as we wrote earlier also, as the domain being x belongs to real number, x is not equal to 1, and the range is y belongs to real number, and y is not equal to minus 4. Correct? These are the two asymptotes. Okay. Now the question here is, can a graph of a function cross horizontal asymptote? So that is a question for you. I'd like you to pause the video, think about this question. It is a very important question, okay? So that is the question for our students. Well, if you say no, it is a wrong answer. The answer is yes. Okay? So give example. Correct. So that could be a very good question for you to think about. Okay. Now, let's move forward and look into the transformation part. Now we are going to discuss the most important issue for which I have made this video is to understand how do we describe the transformation that maps y equals to f of x onto y equals to f inverse x. That is, we are now mapping the transformation between these two functions. How do we do that? Right? So that is what we are going to consider. Now, to do this mapping, there are different ways you could do it. You can check the transformation of each function with the parent function y equals to 1 over x. You could do that. And once you compare, and then you can actually do from the function to inverse function also. So how do we write the transformation with y equals to 1 over x for a rational function? So the idea here is to rewrite the function. So if you have the function of the form like given to us, let's say we have a function f of x equals to ax plus b over cx plus d. In that case, we have to split this function into another form, which could give us a constant plus something else on the top, which is kind of another constant, let's say numerator over some other denominator, which is going to be same as cx plus d. So we have to write it as a fraction shown here. From this, it is very easy to write down the transformation. I will here show you steps of doing the same. So let's begin with the function itself, which is x minus 1 over x plus 4. Now, we want a constant, and therefore, what have I done? We have x plus 4 in the denominator, so I added plus 4 and minus 4. That makes it possible to write one term as x plus 4 and the other term, which is 4 minus 4 minus 1, as minus 5. So that means I could split it into two fractions. One, x plus 4 over x plus 4. The other one, minus 5 over x plus 4. Indeed, this is 1. And then we have minus 5 over x plus 4. You get an idea. Directly, you could see that horizontal asymptote is 1, correct? Horizontal asymptote is 1. So from there, you get an idea how could we split it, correct? So remember, this also reflects the horizontal asymptote y equals to 1, correct? And the transformation we look into, which is the x value is moved 4 steps left, correct? Okay, but let's look into the partial factoring, we call this, as the for the other term. So in this case, we have x minus 1 here, but in the numerator, we have 4x. So to get x minus 1, I will have to again add and subtract 4 because 4 could be factored, right? So remember that part. So again, I added and subtracted 4. Taking 4 common between the first two terms, we get x minus 4. We actually took minus 4 common. Right, x minus 1, not 4, because I took 4 common. So x minus 1 is what we get. And here, combining these two terms, we get minus 5. And therefore, we could actually now write this again as we wrote here as equal to minus 4x. Let me rewrite here, right? Minus 4 x minus 1 over x minus 1 minus 5 over x minus 1. And clearly, x minus 1 cancels, giving us the result minus 4 minus 5 over x minus 1. Correct? Now look here. It is much, much easier to look into the transformation from fx to f inverse x in this particular form. Correct? So what do you notice? Well, what I've done here is also shown you the two graphs. Now this is the graph of the function f of x, and in blue we have the graph of the function f inverse x. So clearly what you notice here is that if you compare the vertical transformation, you're going from 1 to minus 4. 1 to minus 4 means what? It means there is a vertical translation of 5 units down. Do you see that? You're going from 1 to minus 4. So this is 1 for you, and that is minus 4. So you're going vertically down by 5 units. Correct? The other one is the transformation from minus 4 to 1. That is, we have the vertical asymptote which actually moves from minus 4 to the value which is which is 1. So you see that? So that is the transformation which is from 4 to 1, and that is 5 units to the right. 5 units to the right. As far as vertical stretch is concerned, the y values are same, right? So the y values are same. There is no vertical stretch. The horizontal stretch or compression is also the same in both the cases. So the only transformation here is translate 5 units down and 5 units right. And that is how we can actually write down the transformations. You get an idea, right? So that is how we could actually do the questions for rational functions. If you compare the asymptotes, you can get translation. Now, this is important to understand. So comparing the asymptotes, you can get the translation, and that could actually give you an idea of what could be the transformation. And stretch factors can be seen as a coefficient of x, and those will be dealt with in different examples. However, if they are same, that means there is no change in the horizontal and vertical stretches. Perfect. So I hope the steps are absolutely clear. And that is how such questions could be answered. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.